This question, we want to graph y equals 2 to the negative x power. So to start with this, I'm going to plug in some values for x and see what the corresponding values for y are. So if x is 0, y is 2 to the negative 0, which is 2 to the 0, which is 1. If x is 1, y is 2 to the negative 1, which is 1 over 2 to the first, which is 1/2. If x is 2, we get 2 to the negative 2, which is 1 over 2 squared, which is 1/4. If x is 3, 2 to the negative third, which is 1 over 2 to the third, which is 1/8. How about negative 1? That's 2 to the negative of negative 1, which is 2 to the 1, which is 2. Negative 2, 2 to the negative of negative 2, which is 2 to the second, which is 4. And then if I go to negative 3, 2 to the negative of negative 3, which is 2 to the third, which is 8. So let's simplify our table here a little bit. Again, our goal is to graph y equals 2 to the negative x. So this is x, this is y equals 2 to the negative x. So if x is 0, we see over here the y value is 1. If x is 1, the y value is 1/2. If it's 2, the y value is 1/4. 3, 1/8. Negative 1, 2. Negative 2, 4. And negative 3, 8. So let's go ahead and graph all of those points and see what that is going to look like. So I'm going to pull up Desmos here, if I can. And we're going to go ahead and graph those points. So we have 0, 1 is the first point I have, then 1/2. Then 2/4, 3 1/8, then negative 1, 2, negative 2, 4, and negative 3, 8. So looking at this, you can see that we have an asymptote. It's getting closer and closer and closer to the x-axis, of course, right? If it was 4, 2 to the negative 4, 1 over 2 to the fourth, 1/16, 1/32, 1/64, etc. So it's becoming an asymptote this direction, and it's growing that way. So what does that look like? Let's actually go ahead and graph this. Y equals 2 to the negative x power, and you can see it goes through all of those points. So start with a bunch of points, see how it behaves, and then go from there. That's certainly one way to graph it. The next thing that I want to graph is y equals 5 times 1/3 to the x. And again, I like to plug in points to get a feel for what this graph is going to look like, and then go from there. So x, y. If x is 0, 5 times 1/3 to the 0 power, which is 5 times 1. Anything to the 0 power is 1, which is 5. If x is 1, 5 times 1/3 to the first power, which is 5 times a third. 5 over 1 times 1 over 3 is 5/3. If it's 2, 5 times 1/3 to the second is 5 over 1. 1/3 to the second is 1/3 times 1/3 is 1/9. That's 5/9. X is 3. 5 times 1/3 to the third, 5 over 1 times 1/3, 1/3, 1/3 is 1/27. And we get 5/27. How about negative 1? 5 times 1/3 to the negative 1 power. Well, 1/3 to the negative 1 power, what is that? 1/3 to the -1 power. Well, what does that mean? That means 1 over 1/3 to the first. That's 1 divided by 1/3. That's 3. So this is 5 times 1/3 to the -1, 5 times 3, which would be 15. Obviously, -2 is going to be even larger. 5 times 1/3 to the -2. What is 1/3 to the -2? That's 1 over 1/3 squared. 1 over a ninth. 1 divided by a ninth. 1 times 9, that's 9. So this, of course, gives me 5 times 9, which is 45. So I have a whole bunch of points to work with here. 0, 5, 1, 5/3, 2, 5/9, 3, 5/27, -1/15, -2/45. And let's go ahead and graph those on Desmos. So 0, 5 is my first point. And we get 1 5/3. 2 5/9. 3 5/27. You can see how this is going. Again, asymptoting this way, heading back towards the x-axis and then growing this way. Next, we have -115, which will be difficult for me to see. And -245. And let me just go ahead and see if I can show you those. There's -115. You see that one? Whoops. And all the way up here, there is -245. Let's go back to our usual location. We want to see if that's correct. Remember, this is supposed to be y equals 5 times 1/3 to the x. 5 times 1/3 to the x power. Let's hope it goes through those points. And it does.